Imagine you are a senior software engineer at a major tech company. It is 3 in the morning, and the entire platform is crashing. Millions of dollars are vanishing every minute. You finally trace the error to a single file that has not been touched in 12 years. You open it, expecting a standard database query, but instead, you find a 5,000-line block of code written entirely in a language that looks like a cat walked across a keyboard. There are no comments. The variables are named after different types of pasta, and in the middle of it all, there is a cryptic warning that says, "Do not delete this or the sun will stop shining." This sounds like an internet legend, but in the world of computer science, the reality is often much weirder. We like to think of programming as a logical, orderly discipline, but behind the sleek interfaces of your favorite apps lies a hidden world of digital duct tape, spaghetti logic, and pure, unadulterated madness. Today, we are opening the vault of the most unhinged code ever written. We are going into the deep end of esoteric languages, load-bearing bugs, and the absolute chaos that happens when brilliant minds lose their grip on reality. Strap in, because your CPU is about to feel the heat of some truly cursed logic. Let us start with the concept of the load-bearing bug. This is a phenomenon that haunts every veteran developer. There was a legendary case involving an old video game engine where a developer found a strange, useless piece of code that seemed to just loop for no reason, eating up processing power. They did the logical thing and deleted it to optimize the game. Immediately, the entire physics engine collapsed. Gravity stopped working. Cars started floating into the sky. After 3 days of frantic debugging, they realized that the game's internal timing was accidentally synced to the speed of that useless loop. Without that wasted energy, the processor ran too fast for the rest of the code to keep up. They had to put the trash code back in and leave a comment saying, "This is garbage, but if you remove it, everything falls apart." This is unhinged because it represents a total surrender of logic to the accidental. It is code that works not because of how it was designed, but because of a glitch that became a foundation. Then we have the world of what we call spaghetti code, but taken to a level that feels like a fever dream. There is a famous story about the source code for a certain high-profile operating system from the late 90s. Modern engineers who have caught glimpses of it describe functions that are 10,000 lines long. For context, a well-written function should be about 20 to 50 lines. These 10,000-line monstrosities were filled with goto statements, a command that tells the computer to jump to a completely different part of the program. Reading it was like trying to follow a ball of yarn that had been through a wood chipper. If you changed a single variable on line 500, it might cause a printer in a different building to start screaming. The developers who wrote it were under such immense pressure that they stopped caring about structure and started just layering fixes on top of fixes. It became a living, breathing organism of technical debt. A skyscraper held together by chewing gum and hope. But if we want to talk about truly unhinged code, we have to talk about esoteric programming languages, or ESOLangs. These are languages designed specifically to be difficult, confusing, or just plain weird. Take the language known as brainfuck. I am omitting the full name for obvious reasons, but the language itself is a minimalist nightmare. It consists of only 8 commands, all represented by single characters like brackets and plus signs. To print the word hello, you need a block of symbols that looks like an ancient ritual. There are no variables, no easy ways to loop, and no mercy. Writing a simple calculator in this language is a task that could break a sane person's mind. It is unhinged because it is a self-imposed prison. It is programmers seeing how much they can suffer while still technically communicating with a machine. It's the digital equivalent of building a clock out of toothpicks while wearing oven mitts. Then there is Shakespeare. No, not the playwriter, but the programming language. In Shakespeare, the code looks exactly like a play from the Elizabethan era. Variables are named after characters like Hamlet or Ophelia. To give a variable a value, the characters have to insult each other or give long speeches about their feelings. If Hamlet tells Ophelia, "You are as beautiful as a summer day," the computer interprets that as a mathematical assignment. To perform an operation, you have to write a scene where characters enter and exit the stage. It is a work of genius and madness. Imagine being a systems administrator trying to debug a server error, and you have to read through a 5-act tragedy where Romeo keeps forgetting his value because Tippy insulted him too hard. It is the peak of just because you can doesn't mean you should. We also have to discuss the fast inverse square root from the Quake 3 Arena source code. This is an example of unhinged brilliance. Back in the 90s, calculating the inverse square root was incredibly slow for computers, but it was necessary for lighting and reflections in 3D games. A developer, likely John Carmack or someone in his orbit, wrote a piece of code that used a magic number in hexadecimal. It performed a bit-level manipulation that technically shouldn't work, but it produced an answer that was 99% accurate and 100 times faster than the correct way. The code included a comment that literally said, "What is this?" followed by a string of profanity. It was a mathematical hack that felt like a cheat code for reality. It worked on a level of bit shifting that ignored the standard rules of floating point math. It is unhinged because it feels like the programmer reached into the hardware and bent the laws of physics to get a few extra frames per second. Let us look at the code that ran the Apollo 11 moon landing. This wasn't unhinged in a bad way, but in a "how did they do this with so little" way. The Margaret Hamilton-led team wrote code for a computer that had less power than a modern digital toaster. They had to use rope memory, where the code was literally woven together by hand with copper wires. If you made a typo, someone had to unweave the wires and start over. During the landing, the computer started throwing 1,202 inches alarms because it was being overloaded with data from the landing radar. The code was designed to be unhinged enough to realize it was failing and start killing off low-priority tasks to focus only on the landing. It was a primitive form of artificial intelligence. It is disturbing to realize that the fate of the astronauts depended on a pile of hand-woven wires running a program that was essentially screaming at itself to stay focused. Then there is the story of Mel, a legendary programmer from the early days of computing. Mel didn't use compilers. He wrote in raw machine code. He discovered that the memory on the rotating drum of his computer took a certain amount of time to spin. So he calculated the exact millisecond it took for the drum to move and placed his instructions at specific intervals so the computer wouldn't have to wait for the next rotation. He was essentially coding in time as much as in data. When a later engineer tried to fix his code to make it more readable, the program stopped working because it missed the timing of the drum. Mel's code was so finely tuned to the physical hardware that it was indistinguishable from magic. It is unhinged because it requires a level of mental mapping that no modern human could sustain. He was playing a four-dimensional game of chess with a spinning metal cylinder. We also have to talk about the underhanded C contest. This is an annual competition where programmers try to write code that looks perfectly innocent but secretly does something malicious. For example, they might write a program that looks like it is calculating insurance premiums, but because of a tiny, almost invisible typo in a logic gate, it actually funnels a fraction of a cent into a hidden account. It is unhinged because it shows how fragile our systems are. A single misplaced semicolon can change the entire meaning of a program. It highlights that code is a language of absolute precision. If you are off by 1 bit, you aren't just slightly wrong. You are in a different universe. Have you heard of P8? This is a programming language where the code looks like a piece of abstract art, specifically inspired by the painter Piet Mondrian. Instead of text, the computer reads the transitions between different colors and shades. To write a Hello World program, you have to create a bitmap image of colorful squares. If you want to change a variable, you have to change the hue or the lightness of a pixel. It is unhinged because it turns the act of programming into a visual puzzle. You could have a masterpiece hanging on your wall that is actually a functional web scraper or a virus. It blurs the line between data and aesthetics in a way that is deeply unsettling for traditional engineers. Let's talk about the story of the 500-mile email. This is a classic IT legend that turned out to be true. A university admin received a complaint that their email system couldn't send emails further than 500 miles. At first, he thought the user was joking. But after testing, he realized it was real. If an email went to a server 480 miles away, it worked. If it went 520 miles, it failed. He eventually found that a helpful update to the operating system had changed a timing variable. The system was now timing out after 3 milliseconds. In 3 milliseconds, light in a fiber optic cable can travel roughly 500 miles. The code was literally checking the speed of light and saying, if it takes longer than this to respond, the destination must not exist. It is unhinged because it is a case where the laws of physics bumped directly into a default setting in a config file. Then there is the Theric 25 incident, which is a darker example of unhinged code. This was a radiation therapy machine in the 80s. Because of a race condition in the code, which happens when two parts of a program try to finish at the same time and get scrambled, The machine would occasionally deliver a dose of radiation that was hundreds of times too high. The error message on the screen was simply malfunction 54. There was no explanation. Programmers had removed the physical safety interlocks that used to exist on older machines, trusting the perfect logic of their software. It is a chilling reminder of what happens when we trust code more than we trust common sense. It is unhinged because the developers didn't account for the fact that a human could type too fast and confuse the machine's internal logic. Look at the Space Ariane 5 inches rocket. In 1996, it exploded 40 seconds after launch. The cause? A single piece of code that was trying to cram a 64-bit number into a 16-bit space. It was a buffer overflow. The computer simply got confused, thought the rocket was tilting wildly when it wasn't, and self-destructed. The crazy part? That specific piece of code wasn't even needed for that rocket. It was a carryover from an older, slower rocket. They left it in because they thought it works fine there. Why change it? It is unhinged because it was a multi-billion-dollar disaster caused by the digital equivalent of an old receipt left in a pocket. Have you ever heard of intercal? This was the original unhinged language, created in 1972 as a parody of the languages of that time. It includes a please keyword. If you don't say please enough times in your code, the compiler gets offended and refuses to run. However, if you say please too many times, the compiler thinks you are being sarcastic and also refuses to run. It includes commands like forget and abstain. It is a language built on the idea of a grumpy, emotional machine. It is unhinged because it treats the computer not as a tool, but as a difficult coworker who needs to be flattered. Let us discuss the grandmother of all unhinged code, the BIOS. The basic input-output system is the first thing that runs when you turn on your computer. Much of the code in your modern, high-end PC's BIOS is actually legacy stuff that dates back to the original IBM PC from 1981. We are talking about code that was written before the internet was a thing, still sitting there, deep in the silicon, managing how your modern processor talks to your keyboard. If you were to remove those ancient layers, your computer wouldn't know how to be a computer anymore. It is unhinged because the foundation of our high-tech world is an archaeological dig of 80s shortcuts and 90s patches. We are building cathedrals on top of ancient mud huts. What about the year 2000 bug? People mock it now because nothing huge happened. The only reason it didn't was because thousands of programmers spent years fixing unhinged code from the 60s and 70s. Those early programmers used 2 digits for the year to save precious bytes of memory. They never thought their code would still be running 30 years later. It was a global crisis caused by a lazy coding choice. It highlights the unhinged reality that we never really throw away old code. We just wrap it in newer, shinier layers. There are banking systems today still running COBOL code written during the Apollo era. If those few surviving 90-year-old COBOL experts ever decide to stop working, the global economy might actually freeze. Then there is the Creeper, the first computer virus. It didn't do any damage, it just hopped from machine to machine on the early ARPANET and displayed the message, "I'm the Creeper, catch me if you can." It was followed by the Reaper, which was a program designed specifically to hunt down and delete the creeper. It was a digital predator-prey relationship happening in the 70s. It is unhinged because it represents the moment code became alive. It escaped the control of the humans who wrote it and started living in the wires. There is a language called Wife-Tice. In Wife-Tice, the computer ignores every character except for spaces, tabs, and line breaks. You can write a letter to your mom, and as long as the spaces between the words are arranged in a specific pattern, that letter is also a functional program. It is the ultimate hidden-in-plain-sight code. You could have a hard drive full of what looks like empty text files. They are actually a sophisticated piece of software. It is unhinged because it turns the nothingness of a document into the everything of the logic. Think about the Morris worm. In 1988, a student wanted to see how big the internet was. He wrote a worm that would spread and report back, but he made a mistake in the code. He wanted the worm to check if a computer was already infected before moving in, but he was afraid the system admins would just tell the computer to fake being infected to stay safe. So he told the code to infect the machine anyway, once out of every 7 times. This caused the worm to replicate so fast that it clogged the entire internet, which at the time was about 60,000 computers. It was the first internet-breaking event caused by a small tweak in a reinfection logic. It is unhinged how a tiny if statement can paralyze a global network. Let's talk about the Temple OS. This is a deeply unsettling and fascinating case. A brilliant but troubled programmer named Terry Davis spent 10 years building an entire operating system from scratch, meaning he wrote the kernel, the compiler, the graphics drivers, everything by himself. He claimed he was doing it on instructions from the divine. The code is written in a custom version of C called Holy C. It features a random number generator that functions as an oracle to speak with the heavens. The graphics are limited to a specific resolution because that is what he believed was commanded. While the backstory is a matter of mental health, the technical achievement is staggering. The code is incredibly efficient and features things that modern OSs don't have. It is a monument to what a single human mind can do when it is unhinged from the traditional constraints of the industry. It is a singular, lonely piece of digital art. Have you heard of Malbolge? Named after the eighth circle of darkness in Dante's Inferno, it was designed to be the world's most difficult programming language. It is so complex that the first ever Hello World program in Malbolge wasn't even written by a human. It was written by another computer using a genetic algorithm to search for the right combination of characters. The code for Malbolge actually changes itself as it runs, meaning the instructions you start with are not the instructions you end with. It is a language of total instability. It is unhinged because it is a language that humans can't even speak without the help of a machine. It is a digital maze with moving walls. Let us consider the Boeing 737 MAX software. This is a tragic example of unhinged design. The MKS system was designed to automatically push the nose of the plane down to prevent a stall, but the code only listened to a single sensor. If that sensor failed, the code would fight the pilot, thinking it was saving the plane while it was actually driving it into the ground. The pilots weren't even told the code existed in their training. This is the unhinged horror of modern tech. Software that can override human intent without the human even knowing it is happening. It highlights the ghost in the machine becoming a literal threat. We also have the Linux kernel. While it is one of the most successful pieces of code in history, if you look into the drivers section, you will find some truly insane stuff. There are comments from developers who are clearly on their third night without sleep, leaving rants about how a specific piece of hardware from a defunct company is the work of the devil. There are hacks to make keyboards work that involve blindly poking at a port and hoping it doesn't crash the system. It is a massive, collective work of thousands of people trying to make sense of thousands of different pieces of hardware. It is unhinged because it is a miracle that it works at all. It is a babel of digital voices all shouting at the processor at once. What about the Nintendo Entertainment System and its game Elite? The developers wanted to have thousands of star systems in a game that had only 22 kilobytes of memory. They couldn't store the maps of the stars. So, they used a procedural generation code. They used a mathematical formula that would generate the same random stars every time you visited them. It was a digital universe that only existed when you were looking at it. It is unhinged because it was a way of creating infinite space in a tiny box. It was the precursor to games like No Man's Sky, but written on a machine that had less memory than a high-resolution photo. Then there is the Knight Capital Group incident. In 2012, they deployed some new code to their high-frequency trading system, but they left an old, dead piece of code in the system that hadn't been used in years. When the new system started, it accidentally triggered the old code, which began buying millions of shares at the wrong price. In 45 minutes, the company lost $440 million and went bankrupt, all because of a piece of zombie code that should have been deleted years ago. It is unhinged how a ghost of the past can destroy a billion-dollar company in less than an hour. The technical world is fundamentally unhinged because it is a stack of abstractions. You write in a high-level language, which gets translated to a lower-level language, which gets translated to machine code, which gets translated to electrical pulses in a transistor. At every level, there are opportunities for madness. We trust that the logic is solid, but as we have seen today, the logic is often held together by hacks, magic numbers, and bits of spaghetti that no one understands anymore. So the next time your computer freezes or your app crashes, don't just get frustrated. Realize that you are witnessing the unhinged nature of our digital reality. You are seeing the moment the duct tape failed. You are seeing the ghost in the machine wake up and get confused. We live in a world built on a foundation of if statements, and sometimes those statements lead us into the dark. Thank you for exploring this digital asylum with us. Programming is more than just math. It's a human story of obsession, creativity, and the occasional descent into madness. Every line of code ever written is a tiny piece of someone's brain, captured in silicon. Some of those pieces are more unhinged than others. Stay curious, keep your code clean, and whatever you do, don't delete that 5,000-line pasta file. We will see you in the next deep dive into the technology that rules our lives. Until then, keep an eye on your semicolons and stay blessed.